we've got a car, and there are two forces being applied to this car, so those are external forces, and the effort is to accelerate it. And we know that it will accelerate if there's a net external force. So if these are the only two external forces on it, we need to determine if they come out to a net force. So how do we do that? Well, let's just draw a free body diagram. Okay, so I'm going to draw the car. I'll draw that little dotted line that they have there. You have 380 newtons acting at an angle of 30 degrees, and then you have 450 newtons acting at an angle of 10 degrees from vertical. So these forces are going to have y components and they're going to have x components. What I'm going to do is over here I'm going to draw, let's do this. $450 and over here I'll draw the 380. And this is the y direction on both of them. Here you have a 30-degree angle. Here you have a 10-degree angle. Okay, why did I go through all that trouble? Hopefully to help. So in the y direction, I'm going to make the y direction be green. In the y direction, we don't have either force acting directly in the y direction, but both of these forces have a y component. And I'm calling straight up the y direction. So this is the force of the y, or force in the y direction of the second force here, 380 Newton force. And I'll call this the force in the y of the first force, the 450 Newton. Okay, and so what is that component equal to? It is not all 450 in the y direction, but a portion of it. And since that y direction is adjacent to the angle, or right next to the angle, we'll use cosine. Force of y1 equals 450 cosine of 10. And over here, force y2 is going to be equal to 380 cosine of 30. We'll find out what those numbers are. And on this first force, you have 443.2 newtons. And on this one, we have 329.1 newtons. And so to find the y component, so the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. And so what are the forces in the y? 443.2 and 329.1. Add those together. And you get 772 newtons. And that's the net force in the y direction. Okay, we have to do the same thing for the x direction, because the sum of the forces in the x direction are equal to the mass times the acceleration in the x direction. And so we need to know what is the net force in the x direction. That would be this component here and this component here. All right, so we added the green ones together, the y forces in the y direction, because they both act upward. But in the x direction, the 450 Newton, the component of it that acts in the x direction is going to act in the negative x direction. So the force in the x, this will be 472, is equal to 450 sine of 10. And I'm going to put a negative sign in front of it. And it's a 78 Newton force, but it's in the negative direction. What about the second one? That is acting in the positive direction, 380 sine, since it's the opposite side from the angle. And sine of 30 is just 1/2 half of 180 is 190. So the net force in the x direction is a combination of these two, 190 minus 78, which would get you 112 newtons. And this is, I'll put to the right, and this is up. I'm going to take this information and I'm going to take it to a new screen, 772 and 112. 772 up, 112 to the right. And what does that look like? So most of the force pointing upwards, 772 newtons. There's a portion of the force, or some force, that points to the right, and we want to know the overall force, the resultant, which comes from the beginning of the first vector to the end of the second vector. And part of knowing the resultant is also knowing the angle that it acts at. Because the angle of the net force is the angle of the acceleration. So we'll first find the magnitude of it. 772 squared plus 112 squared is equal to the net force squared. Net force, and that would be this force. Net force is equal to, pull up a calculator here. $112 squared plus 770 squared. Let me take the square root of that number. $780 newtons. At what angle? Okay, so tangent of theta is equal to the opposite length over the adjacent length. So theta is tangent inverse of 112 over 772. Back to the calculator. Tangent inverse 112 divided by 772. And I get 8.3 degrees. 8.3 degrees in which direction? Not straight up, but right of straight up, or right of forward. I'll put right of up. Probably should put the angle in there. 8.3 degrees. Right of up. Okay, there's the resultant force. That is part A. And let's remember what part B is. If the car has a mass of 3,000 kilograms, what acceleration does it have? That one's going to be quick. Force is equal to mass times acceleration. I said the mass was 3,200 kilograms. Force, 780 newtons is the net force. And you'll find the acceleration. 780 divided by 3,200, acceleration of 0.24 meters per second squared, and that is 8.3 degrees right of the way it was initially driving, right of up or forward. So go back and look at the picture. You see there's a little force that knocks it to the left, a little more force that knocks it to the right, and both forces are making it go forward. So it goes mostly forward, but also 8.3 degrees to the right, so just off to the right. That's it.